right, folks, welcome to week 5. We're talking this time about probability, and you may have done a little bit on probability in middle school or in other things, and it might just be a subject matter that you're kind of familiar with, but we have to put some math to it here. So this is just our intro to probability. So we have a couple of just vocab words that you'll need. An experiment, of course, is in probability, speaking of activity involving chance. Each repetition or observation of an experiment is a trial. So how many trials did you do? And each possible result is an outcome. So what was the outcome of that trial? And then the sample space, which might be one that you're not familiar with. It's a set of all possible outcomes. Okay, so the first thing we're going to focus on is this idea of sample space. So you have your experiments up here, and then our sample space will fill in down here. Your book or the algebra curriculum doesn't like saying dice. Not really sure why. So I wonder if it's like they don't feel like they can promote gambling in any way. But so anyway, they call dice a number cube. So when you see number cube, think of it as a standard die with just 1 through 6 on each side. So rolling a number cube, how many different things could I land on? Well, I could land on a 1, a 2, a 3, a 4, a 5, or a 6, right? So that was me counting on my fingers there. So my sample space is, and I put like little brackets around it, 1, 2, 3, 4, 5, 6. Tossing a coin. If it's a fair coin, and we have to assume in all of these that we're dealing with fair die, so not weighted die, and fair coins and fair spinners and that kind of thing. So tossing a coin, we could land either on what? Heads or tails. Spinning a game spinner, well, in this instance, we're looking at like the color differences. So we could land on yellow, green, blue, or red. So those are our sample spaces for that. So now, if you look down here, we have to identify the sample space and the outcome shown. So our sample space, again, we have a number cube or a dice, standard die. So we have 1, 2, 3, 4, 5, or 6 for the sample space. And the outcome shown is what it, what's heads up when it landed on it. So the outcome shown would be 4. And then spinning this spinner, our sample space is red, green, excuse me, yellow, or purple. And the arrow would be the outcome. The arrow is pointing on green. Okay, so easy enough for that. So your sample space is what are all my possibilities? Outcome shown is what actually happened. All right, so now if we're looking at probability, so we have an event, which is an outcome or set of outcomes in an experiment. The probability is the measure of how likely an event is to occur. Okay, so they have to be between 0 and 1 if they're decimals, because that means 0% and 100%. So you can't have something that's less than 0% likely to happen or more than 100% likely to happen. So that's why it has to fall between 0 and 100%. And remember, when you have, like if I have 100% here, if I were to change that to a decimal, my decimal point currently is on the right side of this last 0. You change it to a decimal, you move it over 2 spaces to the left, so you have 1.0. So that's why you have 0 and 1 being the same as 0% to 100%. And we kind of probability exists on this spectrum here. So as likely as not show here, where you have from the impossible to the certain. So the impossible is a 0% chance. Like it will literally never happen, right? What's the probability that it will be both 11:04 a.m. and 5:04 p.m. at the same time in the same time zone? Okay, well, that's impossible, right? That just can't happen. A certain probability is the event that it is 100% likely to happen. What is the probability that I will flip a coin and land on either heads or tails? Well, that's 100% because I only have those two options. And then we have this kind of like from about, 20 to 80% here. So 20 to like 40%. And these are ish, right? That's unlikely. So it's unlikely to happen. Anything from kind of maybe 40 to 60% is as likely as not. So it could happen or maybe it wouldn't, right? So like flipping a coin and landing on heads, that's as likely as not, right? Because you only have two options there. A likely probability exists from about 60 to 80%. And then that certain probability. All right, so on this one on the right, we're supposed to write impossible, unlikely, as likely as not, likely, or certain to describe each event. All right, so in a shoe selected from a pair of shoes fits your right foot, and I should say when I say fits, is supposed to go on your right foot. So if you have a pair of shoes, you only have two options, right? You have your left or your right. So if you just randomly select a shoe, it is as likely as not that it's going to fit your right foot, right? Because it's either going to fit that one or the other one. So when you only have two options, for sure that's an as likely as not. Katrina correctly guesses the last digit of a phone number. Well, that could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say the last digit's a 4. Her likelihood of guessing that, that's my 4, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 1 in 10 opportunity to do that, which is 10%. So that would fall in our unlikely category. And you don't have to do these like with actual probability. I'm just kind of showing you right now. Max pulls a green marble from a bag of all green marbles. Well, I would say that's certain. If the only option is green, then of course he's going to pull a green one. A randomly selected month contains the letter R. Let's see. January, February, because February, remember? March, April, May doesn't, June doesn't, July doesn't, August does not, September, October, November, December. So that's 8 months out of 12. That's a pretty likely probability for that to happen. A normal die is rolled and lands on a 7. This is important because a normal would suggest numbers 1 through 6, right? So a normal die rolling and landing on a 7, that's impossible. So it's just so you know, it's impossible when the option doesn't exist. We need to put doesn't there. Doesn't exist. Okay, so there you go. That's your unlikely, likely, as likely as not, certain and uncertain. All right. That is actually all of your notes for today. But this optional homework is called sample spaces. So you're asking here, some of these get a little bit crazy here. So list a sample space for each of the activities on the chart. Remember, the sample space is a set of all possible outcomes for an activity or experiment. Okay, so tossing one coin. My sample space, I have heads and tails. And just remember, these are my funny looking brackets. So sometimes they look funnier than others. Now, tossing two coins. So my outcome, if I toss at the same time, my outcome, I could have, they could both land on heads. So that's HH. The first one could land on heads. The second one could land on tails. The first one could land on tails, and the second one could land on heads. Or they could both land on tails. And some of these, you really might have to think pretty clearly about like what those mean, right? So especially like this column on the left seems to be pretty easy. And then this column on the right, you have to think a little bit more. So rolling one number cube. Okay, we've done this one. 1, 2, 3, 4, 5, 6. Now, rolling two number cubes. I feel like they should be a little bit more clear here, because do they want the sum? Do they want, what is, like, which way the dice are facing, like that kind of thing? Because if they want which way the dice are facing, oh my Lord. So you could have the first one land on 1, the second one land on 1. Oops. And then 1, 2. And then 1, 3. And then 1, 4. And then 1, 5. 1, 6. And then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on and so on and so on. And so that's why I wonder if they meant to put, like, what is the sum of this? Because my sum, if I were to add these up, like, if I can't have, like, the lowest I can have is a sum of 2, right? Because I could have both of them land on 1. So I could have a sum of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because if they both land on 6, then it could be a 12. So that's how I would probably prefer to do that, because this one would be a crazy one to do. Pick one shirt at random from a drawer of 3 pink shirts, blue and green. So sample space, again, we're not looking for the probability, but we have 3 pink shirts. So pink, 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 blue, green. Oh, wait. I'm sorry. 3 shirts of pink, blue, green. So I think probably I read that wrong. Each one's a different color. So pink, blue, green. Picking 2 shirts at random from a drawer of 3 shirts of pink, blue, and green without replacement. Without replacement, that means, like, I'm not picking up a shirt, putting it back, and then picking up another one. So once I pull it, it's gone. So now, 2 shirts at random. Let's start with pink. I could choose pink, blue, or I could choose pink, green. And then I could use, if I did this like blue first, I could have blue, pink, or blue, green. If I pick green first, I would have green, pink, and then green, blue. And then it kind of begs the question, like, does order matter? So does it matter that I first picked up a pink shirt and then a blue one? Or does it just matter that I have a blue and a pink shirt? Because if it matters only that I have a blue and a pink shirt, then the ones that are the same, like this is pink, blue, this is blue, pink, would only be listed once. And then pink, green, green, pink would only be